Hello, my name is Novin, and today I'm presenting our work co-authored by Vyacheslav Komisarenko and my PhD supervisor Melis Kul. To get us started, let's look at an example where we have a weather forecast that informs decisions in a downstream task, in this case a traffic control, where we are interested in setting the speed limit on the road depending on the weather condition. This is a typical setup in machine learning where on one hand we have predictive modeling, on another hand we have a decision-making task that relies on the predictions. Consider two models, A and B, where B is more sensitive towards extreme weather conditions, while A is overall good on different weather conditions. When it comes to evaluation, A is better than B, for instance, because it yields lower error, while if we plug these two predictions into the downstream task, it could be very well the case that B is better than A because, for instance, it yields less accidents. And in this example, the explanation could be straightforward because accidents are highly correlated with extreme weather conditions, and because B is better at these events, thus that's why B is better than A in the view of the downstream task in our scenario. So the takeaway is that the model that's more accurate doesn't necessarily lead to better outcomes. And with this, we get to the idea about evaluation alignment. Since predictive scores that, for instance, produced by log score, or also known as log loss, are not aligned with the downstream value, we would like to come up with a procedure that transforms these scores into a version that is better approximating the downstream performance. And so a critical question here to answer or address is that what matters to the downstream that we can incorporate in our evaluation. Our contributions are threefold in this work. We introduce this problem and we address it by proposing a principled foundation for aligning evaluations and develop a neural network-based alignment model that we assess on real and synthetic data sets. Thanks for your attention, and we are looking forward to your attendance at the poster session. And here the QR code to our paper on the archive is available if you're interested.